Hi, everyone. So nice to see you so numerous coming to see us, to see the kickoff of the Big Picture Community Meetings. This is the one-off of several ones that will be coming. So this one is just to make an introduction, and after that we will have more and more of those meetings that will be rather made for specific questions after that. This one covers the whole Big Picture project from its inception to where we are now and where we think we are going. So without any further ado, we will show you now what is the agenda for today. So we'll first look at the why we've made this thing. So what were the issues that we were seeing that we wanted to solve with the repository? What is its purpose? What were our objectives and how it is structured? Also, where are we now? So we'll look at the architecture, the tools, the security. How do we fit in the fair sharing of scientific data and health data? Now I'll pass on to Jeroen, who will give it a start with the inception of the project.
Yeah, good afternoon also from me, everyone. It's great to be presenting Big Picture today. And maybe before we forget, so Julie just opened the presentation. Julie Boisclair, and my name is Jeroen van der Eyck. And I will give you a bit of the background of the project. So we go back a bit before the project started. And we go back to some research that we did in our research group at the Harvard University in Nijmegen in 2015, I think 2016. So this is about pathology. I think we have a very diverse audience today. So we will make it, we will explain a lot. I will not explain what pathology is. If you're uncertain about that, then you may want to look it up. But this is about pathology, diagnostics based on tissue. And here you can see a tissue block, which probably is very well known to most people in this audience. And in pathology, what we used to do is we make very thin sections, we put it on glass slides, we stain those, and we perform diagnostics. Now, Big Picture is all about pathology. And Big Picture is also about AI, artificial intelligence. And just to give you very brief hints, without going into any detail about why would you want to use AI in pathology, this is a nice example. This is these are sections through lymph nodes of a patient with breast cancer. And the task for the pathologist is to find potential metastatic areas, so regions where there is metastatic breast cancer in these lymph nodes. If a pathologist will find those areas, then that changes the stage of the disease, which also might have consequences, for instance, for the treatment advice that we give. So finding these lymph node metastases is very important, yet it's also a tedious task. It's not easy for pathologists because they have to zoom in a lot, spend time, and still very small metastases can be overlooked because it could be very, very small object. Now, just to give you a sense of what AI could do for you, and this is one of the most simple, low-hanging fruit applications in pathology, I think, is the AI could pre-analyze that tissue section for you and present you the results that you can see on my screen now. So it could already show you in yellow the areas that the algorithm has picked up, the AI has picked up as suspicious for cancer, and could also already give you, for instance, these thumbnails. So pathologists, rather than having to spend a lot of time zooming in, zooming out, inspecting these images, actually pathologists could already be triggered and be led to the regions that are most likely to be diagnostically relevant. And this is just one example of where AI could be very helpful. Now, as I said, this is a study that we started in somewhere around 2015. And in 2016, we decided to organize a challenge, what we call a Grand Challenge, an international competition where we ask people all around the world, AI experts, to help us solve relevant problems in the medical field. And the challenge we called Chameleon. We had two editions, Chameleon 16 and Chameleon 17. And in this challenge, we defined the problem, which is basically the problem I just showed you, right? So we asked participants to build algorithms, AI, to find these metastases in lymph nodes. And to help participants in the challenge do it, we shared image data. In total, we shared almost 1,400 scan slides, which is over 3 terabytes of data. And in the meantime, we had 1,190 parties registering for the challenge. In the meantime, this data set has been downloaded not 1,100 times, but actually over 2,000 times. So what we learned from this challenge is, on one hand, that we can build AI that can help pathologists, which is what I indicated a bit in my previous slide. But what we learned, and what is maybe even more important, at least for today's presentation, is that there is a huge hunger for data, a huge need for data among the AI field. And you can see in the graph, people download the data ranging from USA, China, India. Well, you can see whether your country is on this list, but you can see that actually what I expect beforehand is actually that people downloaded the data also for many purposes other than what we anticipated. So people used this data set for many also very basic AI solutions. And I think I can be proud to say that actually the data set really helped to move forward our field, because it was a great benchmark, and it was a data set that people could use to get used to pathology data, to understand what an H&E image looks like, even if you're not in the medical field. Now, sharing your data was not easy. We used Google Drive for that. Back then, that was one of the most feasible options. And because we had a lot of requests from China where Google is not allowed, we also used this Baidu Pan, which is a similar system. So sharing the data was not easy back then. Now, in subsequent studies, and this is another challenge that we organized, the number of data, the amount of data increased, because we felt that if you want to make clinically useful algorithms, you need much data. It's big data all over. So this is, for instance, the panel data set, and here we shared 11,000 whole slide images. And again, this was successful. People used the data. People came up with great solutions that are on par with pathologists, or even exceed the performance level of pathologists, in this case, grading prostate cancer. Now, a lot of publications in our field appeared, and it's clear that a lot of people work on AI in the pathology field. In this nice publication from the Digital Pathology Association, it is concluded that the absence of publicly available data sets, or the limited accessibility of these data sets with annotations, is actually one of the greatest factors limiting progress in the field of computational pathology. So what we learned here is that sharing data is extremely important. We can develop a lot of AI, but the fact that a lot of people, a lot of companies, a lot of academics have limited access to data is actually one of the greatest limiting factors. I think this is something we see over and over again. It's described over and over again. It's an extremely important topic. Now, this doesn't stop. I showed you 11,000 cases for Panda. Actually, this is a paper from the company Page. They built a foundation model, which is the newest trend in AI development. All have heard of ChatGPT, large language models. You can do similar things with pixels and images, and this model called Virkov is actually trained on 1.5 million whole slide images. So you see that the need for data is hugely increasing, while the availability of data is not. Now, Page managed to do this for 1.5 million slides. That's cool. The thing is, Page is a very well-funded company, and of course, this is doable for, say, a very limited number of parties worldwide. But to really make these data or these models available to a very large audience, also make it available to very small companies, to academics, of course, requires data to also be openly available. So having some of these models is great, but actually it would be great if we can make available much larger data sets also for very broad use by the audience, because that will really drive forward the field. And well, this is one of the very important reasons why we decided to go for Bigpicture, which we will show in a minute. So why a repository? We think that making data available is probably the best way forward to push our field and to make AI really being of value to the pathology community. Now, one of the things probably most of you have heard of is FAIR data, the FAIR principles. And that's exactly what we aim to do in Bigpicture. We try to make the data, pathology data, accessible in a fair manner. And we will get back to that later, but FAIR has to do with data should be findable, so people should know that data exists. It should be accessible, right? You should know how to get access to the data. It should be interoperable, so you should be able to deal with the data, and it should be reusable. You would like to be, for instance, to use standards so that things that you generate can also be used again by in the future by other researchers. So Bigpicture is really about making data fairly accessible.
So this gave us the idea. We wanted to make a repository that was solving several of the issues and problems with the availability of the type of metadata and all slide images to be able to influence computational pathology and really be the catalyst for this change. So if you go to the next slides, so this is we are Bigpicture. And the person that you see on the right-hand side, you have Jeroen and myself, which are the leader of the private and public sector. And then we have our co-leaders, which are Katrin Grunberg, also from Radboud UMC, and Anna-Lena Frisk, that is from Jensen, or J&J, sorry. And then if we look on the next slide, what is our different, just big picture by numbers, if I may say, we have 45 different partners, 10 of which are from the FPA community, which is the pharmaceutical companies. It's 70 million in total, half of which is coming from in-kind contribution from the FPA partners. The other half is coming from the European Union. And it has started the 1st of February 2021. This was the launch date, and it's going to last until February 2027. So for a duration of 6 years. And we are distributed within 15 different countries.
So it means, Julie, that we are just beyond halfway the project.
Yes, exactly. We are at the midterm. And then our values were that we wanted to really be inclusive, because you saw the FAIR data. You saw also that most of the large repositories are not accessible to the public. So making sure that we were inclusive, but also the Bigpicture repository, it's not only a repository where we put slides, it's also a community where that is kind of the center of all this. So to make sure that we can continue to build value, it's not only slides that will be there and that will be static, but it's also a community with which you can interact and with whom you can have projects. We want to be trustworthy, and therefore the legal and ethical frameworks were worked on. So the data is GDPR and will be made accessible. And we really want to be accelerating AI development in pathology. So we want to be a pioneer and a catalyst in the computational pathology field in the near future. And this is the Bigpicture community. And as you can see, it's really multidisciplinary. It's coming from different fields. And it's you, it's me, it's others, people that have not joined yet our community. And we really want as I have said just earlier, we want to be inclusive and make sure that no one is left out.
Yeah, so setting up big picture required us to have some, say, design choices. One design choice is we want to be sustainable all the way. We will get back to that in the end of the project. One design choice is also, as Judy already mentioned, we want to be very inclusive. Another one that is very important, and that's what this is about. We realized very early, and I showed it already in my introductory slides, AI is not static, right? We see that models keep changing, and actually the complexity of models keeps increasing, which is very clearly shown here on this slide from Intel. So what we can do with AI today, is not what we can do tomorrow. We will not be able to really predict what tomorrow will ask from us. It also means that we will not be able to predict what kind of data we have to collect today to meet tomorrow's requirements. And realizing that, we also realized that just making a big data lake is probably not going to help us a lot. We can just make a big pixel lake, put in lots and lots of static images. But it could be that tomorrow we have a question about the data. We want to add more data, more metadata, whatever. And if the lake is just a lake, which is very static, of course, then it could be that we cannot meet that requirement. So what we realized is that actually it would be great if Big Picture could be a big repository containing a lot of data. But at the same time, Big Picture could also be the puzzle piece linking the data user, the person that wants to build AI in the future, to the data contributor. So if you're a data user, you're an academic or you're a company, you want to have data for AI development. It could be that you identify data within Big Picture where you think this is a great data set, but I would need more. I need to understand this data set better. I want to work with people that contribute to this data because I need to enrich the data in whatever form, or I need to understand the data better. Or maybe you want to add more clinical data. So Big Picture could be, let's say, the link between the user and the contributor. Now, that's a great thought, and I think this is something we really want to establish. But it has one serious consequence, and that is called GDPR. If you build, let's say, the anonymous data lake, you can do anonymized data. Your data can be completely anonymized, and then GDPR does not apply. Actually, if you want to have your data pseudonymized, so you want to be able to make that link between the user and the contributor of data, then you have to deal with GDPR, and GDPR compliance is not easy. One of the articles here states as a first sentence, processing of personal data concerning health shall be prohibited. Now, later you will see a lot of text that weakens that to some extent, so there are many exceptions to this. But you have to be GDPR compliant, and GDPR compliance is something that is really complicated, and we decided to really have this as one of the fundamentals of Big Picture. It gives us a lot of opportunities, but also it creates a lot of complexities, which we will see in the future. Now, the way we set up Big Picture is as a central part, we have the repository. So the repository basically is, let's say, the hardware and the software stack to hold images, but also to hold AI algorithms. So how we have the storage, we have a layer of security, and we have the compute. We can have a lot of data in the repository, and we can also have AI algorithms there. And this is mostly based on existing Elixir technology. So we have not started from scratch building this, but rather we used existing technology, and we made this also, say, available for storing images. Around the repository, we will build what we call the platform. And the platform holds, say, the tools for data processing, quality management. We will also focus on AI algorithms, user interfaces, and also we will look at the regulatory landscape and see how we have to deal with the regulatory part, ethical considerations about making a very big repository of personal data. It's important to stress that in Big Picture, we will focus on algorithm development, AI development, but we will only do this as a, let's say, enable people to build AI in the future. So we will not build in Bigpicture an algorithm for breast cancer or prostate cancer, but rather what we will do is we will build, let's say, more generic AI tools that can help people in the future to take big picture data, take the AI frameworks as you wish to use that data to build specific AI algorithms. So it will be very generic rather than very specific for certain use cases. Now, around the platform, so the platform will be fed with data, but also with AI algorithms. And around that, we will build the community, which is basically you all today. So the community is very inclusive. Anyone that is interested in AI and pathology can be part of it. If you're a pathologist and you think that you can add value by adding your data, your images, maybe your expertise by annotating cases, by reviewing cases, but also if you're a data user, you want to build AI in the future, you can be part of this community. And the community is regulated, is controlled by what we call the honest broker environment. We'll get back to that later. And of course, there should be a bidirectional value stream here, right? So for everyone in this community, if you bring in value, you should get out value. So everyone, it should be clear for everyone what's in there for you and what it will cost you. To be honest, Julie, I'm a bit lost here where we switch slides.
I think this one is still yours.
Okay, then I just continue. So the way we see it, I already told you we have data in the platform, in the repository, and we will have AI. So the way we envision it is we have 4 what we call usage patterns. So on one hand, very straightforward, you can download data, which is what we used to do, for instance, in the Comedian challenges. So there is data, you can apply for access, and if the access is granted, you can download the data, you can build AI. Now, we realized that it could be that sometimes we have data that you want to use for testing your AI algorithm, but actually we do not want to release that data. We don't want you to get direct access. So we can also provide indirect access to data, which is the bottom right box here. So if you want to validate your AI on data that you're not allowed to see, for instance, for benchmarking, for regulatory purposes, you could upload your algorithm and actually get back the results of your algorithm on a specific data set. So you will not get direct access, but you will get indirect access to that data set. Only your algorithm can see the data and process the data. Now, on the other side, we have algorithms that you can download. So you can just download an AI algorithm like in an app store, which we all know. And then the algorithm could run on your own hardware, for instance, or in the cloud somewhere. The other direction would be you could also have the algorithm live in the Bigpicture environment. And actually, you could only use that algorithm by uploading your images and getting back results from the algorithm that the algorithm has processed. So these are the 4 usage patterns that we want to enable within Bigpicture. And these 4 will give you very different ways of dealing with the platform. So I think it's very good to keep that in mind.
Thank you, Jeroen. So this is how we are structured as an IMI project. So you've seen earlier the work package 1. So we are doing the management of this large complex project. But we have also a work package that is working on storage and infrastructure. One that is more collecting all the data. So we call them the node coordinator. And then we have the work package 4, which is doing the generic tools. So the AI tools that Jeroen was mentioning earlier that will help with the access, the analysis, and a few models. Then we have a regulatory work package. So there we discuss a lot of the legal questions and also the ethical questions around the use of AI in the health and in the pharmaceutical industry. And we have also at the basis the sustainability platform, because this was really started from the beginning, unlike a lot of other IMI and IHI projects where sometimes it's left out at the end, and it's more difficult to have these types of projects that are sustainable. So if you see this, it looks complex, but this is for a complex project. We need multidisciplinary teams, hence we cannot function in silos within these work packages. So you see a lot of interaction between these projects. At the heart of it, you have what we call the data collection or the node coordinator. And you can see that we have very various organs that we will sample in the clinical settings. So cancer, kidney, the liver, the lungs, the skin. We also have some clinical studies, and then we have the non-clinical node that will collect the slides from the toxicology studies from the pharmaceutical companies. So to just a little bit back, please, I'll just finish the, sorry, Jeroen. So the coordination is done by us, Work Package 1, but we also have a managing board, and we are interacting as well with external groups like a NITIC advisory board and also a multi-stakeholder advisory board. So there is an external eye also on what we are doing. And you see the different work packages that I've mentioned before. So we have also in pink those task force. So one is taking care of the architecture, so everything is connected nicely, because there are a lot of moving parts in such a complex group. We have also one that is working on the metadata and the nomenclature. This is as well a very big success that we have had, to be able to have a kind of standard in the type of metadata that is needed for computational pathology. Then we have also the honest broker, so how you will access the data, but make sure that the patient data is protected. We have the GDPR, so make sure that the legal part is all there so we can function. And then we also have a quality coordinator center. So this is also important. Someone was asking in the chat, how do we address this quality? So we have the node coordinator that will be looking at what is going up. We have the submitters also, or the providers that will also be making sure that they are having good quality. But there are also some tools that we would like to build to assess the quality of the slides and the quality of the metadata that is associated with the slides. So we will provide 2 million slides. We are collecting 3 million slides, 2 million of which are preclinical, so animal studies from different species that will be spanning across the 60-ish organs that we are collecting for such studies. And then for the clinical side, we have 1 million slides. And if you press again, you will see that the clinical slides, unlike a lot of the publicly available collection at the moment, they will be very diverse. So for the non-neoplastic disease, the collection are rare, so it's going to be quite diverse. And if you press again, you will see in the cancer, it's not only about prostate cancer or breast cancer. We will have way more diversity as well.
Yeah, so as I said, we aim for fairness. So we want the data to be fair. And what I would like to do is briefly show you some of the things that we established in the first 3 years of the project. And I would show you how we want to make this fair. So this is not exhaustive, but to give you a feel for what this is, the way it is shaping, and how we try to be fair, compliant with the FAIR principles. So definability, we have different ways of how you can know that data exists within Bigpicture. And one of these, this was taken from the IDA Data Hub, which is a smaller scale version of Bigpicture in Sweden, in Linköping. We will create landing pages for data sets within Bigpicture. So it means that there is a landing page which is findable through Google. It has a DOI, so you can link to it also in your publications. And this landing page describes in detail what is in the specific data set. So Bigpicture will contain data organized in data sets. And this page describes nicely in text, but also in a number of predefined fields, exactly what is in that data set. So how many cases, how was it collected, what are the inclusion criteria. So this helps you to find the data. Now, of course, other ways of finding the data is going to the Bigpicture portal and just using the search engine, which is under construction. So you can also search the repository directly. For accessibility, if you find a data set that you're interested in and you want to get access to that data set, we will provide a lot of tools to make that as easy as possible. So the thought is that in Bigpicture, because everything has been collected under very, very clear regulations and with clear contracts, it's very clear from the start who could get access to which data. So if you're, let's say, a company, you want to have access to data also for commercial use, then it should be very clear from the beginning. If you identify a data set, this data set will probably be available for me, right? I'm eligible to get access to that data set. So accessibility, for instance, we will be taken care of by having a login system, which is called Life Science RI, Life Science Login, which means that you can just log in through existing platforms. So you can just mostly log in with, for instance, your institution credentials. Then for accessibility, we will use an existing structure, which is called RAMS, Resource Entitlement Management System. And RAMS will help to streamline that process of getting access. So if you find a data set, it should be very clear whether you probably can get access to that data set. So you can put it in your shopping cart and you can apply for access through this standardized mechanism. Then you have to fill out specific forms. So you have to make very clear who you are, what you want the data to be used for. And then RAMS will take care that the permission is asked to the proper people. So we will see what kind of data set is it. So this request will be handled in a very standardized manner. And you will get to hear the results, whether you get access to the data set, and also then the access is arranged through this system. Now, a very important mechanism in the background, and I already mentioned that, is the honest broker environment. So the honest broker is a collection of say an office personnel, but also technical tools that will completely take care of this process. So the honest broker will take care of that. It's very clear for you. You can get to the honest broker with your questions. It's very clear how to get access to a specific data set. So there should not be any unclarities there. The honest broker will take care of that. This process will be as easy as it can be, and that you can get access in short time frame to the data that you are eligible for. Now, in terms of interoperability, we will build tools. And one of the tools we already produced in the project is this. It's not easy to see this, but this is actually a GitHub repository for a dichomizer. In Bigpicture, we aim for standards as much as possible. And one of the standards we selected is DICOM for the images. Now, DICOM is not that well represented in the pathology field, so we decided to make software to convert, let's say, the whole plethora of images, that is image format that's available in pathology into this DICOM standard. So there is no excuse anymore for people not to be using DICOM. Also, we will provide tools, for instance, for viewing images and dealing with images and with sets of images. We will use Cytomine. Cytomine is an SME in Belgium that will take care of this. So Cytomine has a very nice interface to deal with the images, also make annotations. And lastly, for compute, we will use the Grand Challenge platform, which is developed within Radboud Nijmegen. And Grand Challenge is a platform that can really help to bring your AI, so containerize your AI and bring the AI to the data. So especially for indirect access to data, Grand Challenge is a great solution. Now, reusable, the R of fair. Reusable, for instance, means that we established a very extensive metadata standard. So we had a task force on metadata, and with a lot of different stakeholders, different parties, we defined a metadata set, which is on one hand very extensive, so it contains a lot of rich metadata. At the same time, we try to keep it such that it's also feasible for data providers to provide this data. And this standard will be publicly available in the near future. So we also hope that other initiatives in the infrastructure space can make use of this, and that it can be broader than just big picture, because a common metadata standard, of course, would really benefit also the interoperability and reusability of data across different platforms and even across different modalities. Now, to help the user, we are building tools like this one. This is called Slide Tab. And this is a tool that can help you to build data sets in your own local environment. So if you're a data provider, pathology lab, and you want to participate in Big Picture by providing your data, it's still not straightforward to build a data set, have all the images in DICOM format, collect images, have your metadata, combine all of that, and be able to upload that package into Big Picture and comply with the Big Picture standards. So to help you build data sets, we built this Slide Tab tool, which can help you. It can link to different systems. You have to tailor it a bit for your own local situation, but it can help you to link to your lab management system, to maybe your image management system, and extract data, combine data, and build data sets which then can be used within Big Picture. Now, I already told you we will focus on AI development in a very generic way. I will not go into any detail here because it's really beyond the scope of today's presentation. But for instance, this is a publication that we did in our work package 4, which is on AI and user interfaces and tools. This is an algorithm which we call streaming with attention. And this is an algorithm that actually can help you to build AI without having to annotate every single image by, say, an expert pathologist. So rather than, for instance, the example I gave for the lymph nodes in the beginning, rather than having a pathologist draw every lymph node metastasis to train an AI system, we have shown here that with this approach, the only thing you would need to train such a model is a slide level label. So you should be able to say this slide contains cancer or this slide does not contain cancer. And this method will itself find out which pixels and which region of that image contains the cancer. And in this publication, again, I will not go into any details. We showed that we can have very state-of-the-art results without having to do this tedious annotation of pixels. So with that, we would also like to help people building AI and make life much easier, because we don't need a very scarce and expensive pathologists for doing all these annotations. And we can alleviate that part of the work and still have state-of-the-art solutions.
And now for the sustainability, as I said at the beginning, the sustainability was really built from the get-go when we started the project. And it's a community-based approach. So often the people that are currently in Big Picture and also their profile, they will also be part of the community. And it's a bi-directional value stream. So the contributor and the user, but also non-clinical and clinical partners. So we want to take all the advantage of really the transfer learning also from different domains that are doing some specific model. And also the platform, there is within it, and you've talked about it a lot Jeroen, you have functionality and the data that really coexist. So we think that this also will be helping the sustainability of the platform. And also the repository will be dynamic. So we really plan from the start of the new company to have a growth plan already in place as we press the go button. So we more or less end like we have started. This is again the community, which is very diverse. I don't know in which one you are fitted, and maybe some we have forgotten. And if we have, please put it in here. And then I think I will close it here with the opportunities. So when we started this project, there were a few kind of type of approach that we were looking into. And now there are like some new emerging properties that we need to take into consideration. So if we think about the foundation model, this was not something that was really in vogue, at least in histology when we started this, or something that we thought would be coming. The multimodal AI approach also. So, and there will be in the years to come, new emerging properties that we don't know of at the moment that will be coming out. And we will, we try to make sure that the repository is really able to adapt to those new emerging properties so it can continue to bring value also in the future.
I think that brings us to the end of the presentation.
Yes.
So I will stop sharing my screen. I think we still have time for questions.
We do. There are a lot of questions. I was monitoring them. A lot of them also are quite specific, and I think I don't know, Jeroen, for you, but some could go to some other people that are probably more knowledgeable than us. So I don't know how we want to go, if we want to go through them all, or if we want rather to collect them and then answer them and then send a document to this community with the answers.
Yeah. Yes, so the slides will be shared. So I'm looking at the comments now. So I can just, how do you want to do it, Julie? So I can, we take some of these questions now, right?
We can, yes. Yeah. So we can start from the beginning, maybe?
Yes, the question, will AI algorithms developed in Bigpicture be available on an open source basis? That's definitely the goal here. Yes, so everything that is developed within Bigpicture as part of the project will be available. Of course, if some parties develop algorithms in their own projects, of course, that will not always be available, but everything from Bigpicture should be as much as possible available. Julie, the question, what kind of images? All stainings or just H&E?
So for the non-clinical, it's mainly H&E. For the clinical, I think we have both. So there will be H&E and also molecular localization type of slides. So we've built that in. Some of the images also we can have annotation. I think this was on one of your slides as well, Jeroen. So we are also building the metadata to be able to submit annotations with the slides.
Question, whether we also have the appropriate context of use. So for instance, in Toxopath, will you have a hazard ID? And in human pathology, will we have diagnostic, prognostic information?
So for the tox, you will not have the type of drug because this was IP information with what was not shared by the pharmaceutical companies. And then for the human pathology, you will have the diagnostic that will be provided with the images. Mm-hmm. I think for the AI Act one, I was answered that this is a European project, hence we will be following the European legal aspect.
Definitely, yes. So this is an important one. When will the repository become public?
So I've put 2027. I know that there are also discussion in the sustainability group to see if we could start that earlier. So I think this still needs to be discussed. How is the validation of the AI algorithms that are integrated?
I'm not completely sure if I understand what it means. So
a little bit like, for example, the artifact detection. How did we validate it that it was working?
Yeah, so the algorithms that we will produce, of course, they are produced in a research setting. So we will validate it as we always do in our research. So we have external data sets. We try to have data sets from centers that were not used for the training. But of course, these are not certified algorithms, so they do not have like a CE certification. But we will validate, as we always do, with as much as possible external data.
And then John had several questions. This is mainly related to non-clinical, like how will you ensure the quality of the diagnostic that are in there? So John, we are collecting 2 million slides from non-clinical. You understand that we will not go through them and re-diagnose everything. And I think each and every of the 10 large FPA partners that are in the group, I think they are, trustworthy companies and with probably high quality pathologists. So we have confidence that the quality of the diagnosis will be there as well. And then from Grashina, do non-clinical studies include only toxicological studies or also various preclinical animal model? I think this was answered also later, where it's mainly toxicology studies. These again are
for you. This is for you,
yes.
Julie. Are health authorities receptive to the use of such database and AI approaches for WOE approach to hazard ID risk assessment?
So part of the project, we are interacting with the health authorities. So we did it in the first year for digital pathology, and now we will be interacting in the, I think it's at the end of this year, with the Japan health authorities. We did FDA, we did the EMEA, and for next year, we'll do the round again, but this time not around digital pathology, but around computational pathology and the use of AI in the toxpath industry. So it was planned from the beginning that we would have an interaction with the regulators.
Yeah. How do you ensure diversity within the data sets to ensure, for example, heterogeneity of ethnicity? The diversity, we will look at that by, let's say we have a node coordinator board. I think Julie showed that. So the data collection is organized in different nodes. For instance, we have a node for lung or for skin. There is one party that is responsible that will collect data, or say orchestrate the data collection through different parties. Those pathologists will look into the diversity. So we will try to get a lot of diversity, let's say over different centers, different scanners. Ethnicity is a difficult one because I know at least in the Netherlands, ethnicity is never recorded. It's not even allowed to record it. I'm not sure in other European countries, but I don't think that we will be able to really do that. But maybe if Katrien Grunberg is in the call, she can give more insights into that.
Maybe also what I would suggest is one of the topic for one of the future community meeting could be taken up by the node coordinator, and then the node coordinator could answer all these types of questions, because there were quite a lot regarding those. Have you been making sure that the DICOM conversion doesn't lose any data of the original images? Is the conversion done by reverse engineering the file system, or it is done in collaboration with scanner providers?
To be honest, I can't answer that question. I think it's a good
what
one.
I would suggest is maybe one of the topic could be on the dichomizer, and maybe rather on all the tools, going more a deep dive in all the tools that were developed for the platform and that will be made available.
Yeah.
Can Cytomine now open slides with DICOM format? I think so, yeah.
It is in the pipeline. I'm not sure if it's
Yes.
already established, but at least it should at some point.
Is the preclinical or clinical data organized by provider? So for the preclinical data, it's going to be one large pool. So you will not be able to re-identify who is the pharmaceutical that has provided the study. This is because of IP information, because sometimes toxicity is like a thumbprint, right? You can recognize what type of drugs that was used just by looking at the type of toxicity. Hence, we made a kind of large pool of data. So this is diluted within the 10 FPA partners that will be providing some slides. As for the clinical data, then the providers will be identified. There will be also, as was shown, these landing page, and on the landing page, there is a place where you can contact these people. Can we connect through a standardized structure report with real-world data? SSR will have metadata about which AI. So I'm not. Do we? I'm not sure, and maybe this is something we should put also with the node coordinator meeting. I'm not sure they will append the report. For sure, not for the pharmaceutical data. So the metadata, it consists of about 150 data, and from those, it's rather like what is the species, the age, the sex, these types of information, and then if it's a control or a treated for non-clinical, and the patient, you will have the diagnosis, and for us as well, you will have the microscopic findings and the gradings. So this is how it's going to be structured. So I'm not sure about the structured reporting. So maybe this is something I would need to understand better the questions.
I think it's not in scope now, but of course we can consider it. I also don't know enough about this. I don't think that it's being developed now, but I think it's a good thing that we can take further.
Will user be able to log requests that will be considered by contributors? Yeah, you will be. That's why we are building also these types of community. So if you don't find what you need on the database, so in the database, you will be able to sort through what is in there based on what you want. I want rat liver hepatocellular hypertrophy of this age. You do the same for a disease in the human, and then you select the one you want, and it's going to go through the honest broker where the approval process will ask the person that is owning these slides if you can use them. And then if you do not find what you want, there will be a way, sustainability group make sure that there will be a way that you can connect with the community so you can build a new data set that includes what you need that will be then made available on the platform at a later stage.
Now, a tricky one, how many slides are already available and collected at this moment? So the amount of slides is in the thousands or 10,000s and are not yet available. And the reason for that is that, as I presented, we want to be GDPR compliant. Now that is complicated. So we have needed a lot of time to get to the, let's say, the legal documents, a data sharing agreement that fits all the purposes. So it means that a lot of slides have been collected in the background by different parties, are ready for upload. But before all the legal stuff has been finalized, we are just not in a position to upload any data. So basically the repository is ready to take data. The providers are waiting to be able to provide the data. But I would say this hurdle, this legal hurdle in the middle has so far prevented us from really doing the big large-scale upload, but we are in the last steps of that legal process. So we expect to start uploading cases within the next few months. So at this point, there's not so much data available. The availability of data for big picture parties for the project is then quite straightforward. We are also working on the legal side of people outside of the consortium to get access to data. So please hang on. It will take still a bit more time because it is a very complex project. We are working on these legal challenges, but it will be solved. It just takes time.
Thank you. Then I think there was a lot of questions about how to join Bigpicture, but as we said, and there were also some answer in the chat. Stay tuned. It's not yet available for people that are not within the consortium, but it's gonna come at the latest in 2027. But we are, as I said, discussing to see if we cannot onboard also not new members, but rather future users in the before the end of the action.
I see quite some comments on conversion to DICOM and quality loss. I agree that probably will happen. At the same time, we have to realize that if we use any kind of JPEG compression, we already accept the loss of some quality, right? So I think it's true, but this is a thing that we already have to deal with in pathology.
So what will actually happen with the project after 2027? So we have we are trying to see how we will organize the company. We call it Bigpicture NewCo, or at least the repository will leave after. So I think this could be also a topic for the future as well. So we want to organize it in a way that it's going to become sustainable, and there will be probably memberships and then some services that will be provided on the platform. So we've already made like the kind of sustainability plan with the financial plan. So this is all in the making. And then, as this is a very interesting event, are there future plans to hold similar events? As I started, this is just the kickoff meeting from the Bigpicture community. And as we are gathering some of the topics, these community meeting will happen at a regular basis, where we will, instead of giving this kind of large overview, we will deep dive into specific topics like the node coordinator, for example, the tools like the dichomizer, where it's not going to be myself or Jeroen, but really the expert that were there, although Jeroen is an expert, but the expert that will come and will really tell you more in details how these tools were built, what are their challenges, and also how they will be used in the future. So it's really just starting.
In the meantime, Katrien answered the ethnicity is tackled by diversity in contributing centers. So we will not be able to explicitly focus on that. Mostly, I think, because it's legally not possible in Europe. But because we will have a large spread of centers, there will be a natural spread in ethnicities.
Does Bigpicture only have tuxPath slides with typical lesions? No. So this will be a 2 million slide data set. So there will be a lot of within the action, so the kind of contract that we wrote at the beginning, we are not allowed to give only control slides. So we need to have less than 50% of control slides. You know, the way we are functioning, we look at control and IDOs. So for studies without lesion, you have 50-50, but you're not allowed to give more than that. Hence, we will have like a not only control. It's not allowed to have only the background changes. So we hope to have a lot of diversity. Also, we put away, because we have a non-clinical coordinator. We will monitor what type of findings that are in there, what type of species, what type of organ. We will assess what are the gaps, and we will try to make sure that the database is as diverse as possible. So we arrive at the top of the hour. I think for the last questions, we will probably have to answer them via email. We will also provide access to this presentation, to the recording, if you want to forward this to friends and colleagues. And with that, thank you, everyone.
Thanks, everyone. It's great to see so many people show up.
Thank you. Bye.
Bye.